The following is an example of finding the derivative using inverse tan. So we're going to apply the rule here. The derivative of inverse tan is 1 over 1 plus x squared. So the derivative then, the constant stays. Inverse tan is 1 over 1 plus this part all squared, so pi x to the 4 squared, multiplied by the derivative of the argument for the inverse trig, in which case the derivative of pi x to the 4 is 4 pi x cubed. Simplification then, we'll put the 4's together to get 16 pi x cubed over 1 plus pi x to the 4 squared. In the following example, we're asked to find the derivative of sine inverse of 2x divided by cosine inverse of 2x. This is a quotient, so besides using these two rules, we also have to use the quotient rule. So the derivative then, as per the quotient rule, is the derivative of the top. So the derivative of sine inverse is 1 over root 1 minus 2x squared times 2, the derivative of 2x. So that's the derivative of the top, keep the bottom. So that's times cosine inverse of 2x minus, keep the top, so sine inverse of 2x multiplied by the derivative of the bottom. So the derivative of the bottom is the same as for sine inverse except with a minus. So it's going to end up being minus 2 over the square root of 1 minus 2x all squared, or 4x squared, all over the cosine of minus 1 is 2 of 2x all squared. We can simplify this a little. This and this are the same, so we have a common denominator. So what we're going to end up with then is putting these on top. 2 cosine inverse of 2x plus minus minus 2 sine inverse of 2x, and that's all going to be over that root 1 minus 4x squared, which, and all over that, so that can go up here, cosine inverse of 2x all squared. Now if you struggle with the simplification, don't worry too much. Remember, this is a course about calculus. We're very concerned about the derivative part, not as much about the simplification. So make sure you're understanding where this comes from and then slowly work towards being able to get that.